All right, let's get started here. 5-4, we're talking about graphing linear equations. And if you're looking at that first page, it's kind of interesting. That chart on the right side is dealing with activities that we conduct, that we perform, and how many calories per minute per kilogram they burn as you do those. And it's kind of interesting. We talked a little bit about it in the last class. Can anyone find which activity burns the most calories per minute per kilogram?
Running.
Specifically?
Running.
Specifically? Per kilometer? Yep. So 3.7, running 3.7 minutes per kilometer is going to burn 0.252 calories per minute per kilogram. What's going to be the least calorie burning activity on that chart?
Eating. How is eating? No, it's word processing. No, it's sitting quietly.
It's sitting quietly at 0.021. Eating is 0.23, so super close. But I'm thinking, how in the world, sitting quietly, will you burn anything? Can anyone explain that to me? Because apparently you do. Jenna?
Well, actually, you're never, just still, because you're always, in motion.
Yeah, so even when I'm standing here, so let me try to do nothing right now, real quick.
You would be dead.
I'm trying. Not that I will, but okay. And I can be pretty still, and even if I'm barely, what am I doing constantly?
Breathing.
I'll try to make it emphasize. Breathing.
And your heart is beating.
Heart is beating. And you know what? My body's going through all these processes. So I'm burning calories as I stand here. But then I think I play basketball, and that gets me 0.138 calories per minute per kilogram. What other sports are like basketball? So what other sports are like basketball? Well, looking at the chart there. Dancing. Yeah, you actually perform just a little bit. You burn a little bit less dancing. Some of you do dancing, and you're going just 3 thousandths less. Anything else that's close? What about football? It's pretty close, isn't it? And then I look at, swimming. That's kind of a lot more. Why would football not burn as much as swimming? Because I thought, yeah, Jack?
Because in swimming, you have to, tread the water.
Okay, and what parts of your body are you using? Every part, right? Every single part is being used. Your upper body, lower body. In football, you're going in spurts. You're using a lot, boom. And then you have to pull back, boom. And you might get these quick jolts and a lot of intensity at once. But swimming, it's a constant, pretty intense thing. Word processing. Does anyone know what that means?
Math.
No, it's just typing. They used to call it word processing, typing. It burns 0.027. More than eating and sitting quietly. And then I'm thinking here about jumping rope. They call it jumping rope. Why is jumping rope more intense than football? Yeah, have you ever done jump roping or jumping rope? I guess. Yeah, you're in football, it's intense, but when you're jumping rope, you're doing this, and you're doing this constantly. You're burning those calories at a high rate. And look at lift or weight training. That's not as high as I thought it would be. Why is that? Okay, you have breaks, and you're focusing usually on either one or a set of a few muscle groups at a time. Whereas swimming, you're doing all of them at the same time. So I hope those are understandable. And jumping rope. Yeah, I used to love doing that actually in elementary. The games we used to play, jumping rope. But anyway, I don't think I can do that. I might break something. Let's look at our lesson here, linear equations. The reason they have that, by the way, is because you can come up with a pretty complicated equation that would be a line, and that's what this whole lesson's about. But because of the complex numbers, we're not going to use that today. Linear equations hopefully you understand that linear equations, when graphed on a coordinate plane, would form what shape?
A line.
Okay, good. A line. Linear, a line. So they're going to form a line. But there's a little bit more to it. Those are equations that can be written, and that's a key phrase, that can be written in what we call standard form. So that's the key to this definition. Any equation that can be written in standard form is a linear equation. So I'm going to put here the parallel or the link. Ready, guys? If an equation can be written in standard form, it has to be this whole thing, linear, or a linear equation. If it's a linear equation, it can be written in. So do you see how they are synonymous, basically? Linear equation, standard form, they're almost the same thing. Okay, so write that down. But I have a very important question. What is standard form? What a great question. Because if we don't understand standard form, then this definition doesn't make too much sense to me. So standard form, and this is a key to the lesson, especially for this first half. Standard form is a specific capital A, lowercase x, plus capital B, lowercase y. I'll make that clear so it's not looking like it's uppercase, equals C. So AX plus BY equals C. That's a very important form to know. All right, notice A, B, and C are capitalized, and X and Y are not. You okay with that? Does that look clear from that little board, a little definition on the board? Okay, good. All right, X and Y are variables. A, B, and C are numbers. Okay, so please remember that, and I'll write that up there. Not only are A, B, and C numbers, there are specific types of numbers. So you need more. This is not everything for standard form. You need to know this. It's in the form AX plus BY equals C, where A, B, and C are integers. So A, B, and C have to be integers. That's one stipulation. There are two others. And I'm going to tell you something a little bit more about that after we write this down. So A, B, and C are integers. A is greater than or equal to 0. A is greater than or equal to 0. And last stipulation here, and this is a tough one to phrase. And A and B are both not 0. And that's a tough one to phrase. A and B are both not 0. Okay. I was debating about this last night because I was looking at standard form, and this definition can change later on. Next year for you, if you go to geometry or Algebra 2 and further on, this will not be as restrictive. And I just want to lay this out there so you know I understand what you're doing later on. It's going to be AX plus BY equals C. They're going to say where A, B, and C are real numbers. Okay, they're real numbers. But I'm using integers because I want to make it simpler for you for now. Later on, you'll be able to handle real numbers. They're also not even going to mention that A has to be greater than or equal to 0. A can be any number that's real. But A and B are both not 0 is part of the stipulation. So this is what I want you to get because I want you to make it simplified. Yes, ma'am?
How can A be greater than or equal to 0 if A and B are both not 0?
Okay, good question. Let's look at this last part. A and B are both not 0. Does anyone know what that means, that A and B are both not 0? What does that mean? Because I need to look at it really through grammar. Yes, ma'am?
Doesn't it mean that one or the other can be 0 but not both of them?
Okay, one or the other or neither can be 0, but they both can't be 0. Does that make sense? So, can A be 0? According to my definition, can A be 0? Okay? It can, because A can be greater than or equal to 0. But can A and B both be 0 at the same time? And the answer is no. Not if it's in standard form. It wouldn't be a linear equation.
Can A be 0, or can A be the only one that is 0?
Great question. What do you guys think? So he asks, can B be 0, or is A the only one that can be 0?
Well, by themselves, one of them can be 0. But if they're together, only one of them can be 0. Well, neither of them can be 0.
Okay, so let me see if I can clarify that. Can A be 0, everyone?
Yes.
Can B be 0?
Yes.
Can A and B both be 0? No. Okay, can both of them not be 0?
Yes.
Okay, so you see there's some variety there. And yeah, that is tough, but I'll try to drill it over and over again. Okay, ready guys? Looking at just the form, what are the variables? See if you were paying attention. X and Y. What are the integers? A, B, and C. That means they're going to be numbers, okay? They're not going to be like, you're not going to have the letter A in there or the letter B or the letter C. These are going to represent numbers, okay? All right, looking at that form, there's one more thing I really want to emphasize. You have your X term and then your Y term, and they're both on one side, aren't they? Aren't they both on one side? You got to get into that to make it standard form, okay? So we're really picking up standard form, aren't we? We are. Because really, standard form helps me out with a lot of other forms that we'll look at next chapter. Okay, let's look at example 1a, and let's see how we can use standard form to help us to understand if an equation is a linear equation. So let me ask this question again. If an equation can be written in standard form, what's the graph look like? It's a line. If the graph is a line, what do I know about the equation? It can be written in standard form. Yep, it can be. Whether it is or not, we'll find out, but it can be, definitely. Okay, A, 4x equals 7 plus 2y. All right, looking at that equation, is that in standard form? Yes or no?
Yeah.
Okay, I hear yes and no. I need someone to help me out. Is it?
Yes.
And why? Or is it not? And why not? Maggie? What do you think? It's not.
The X and Y terms aren't on the same side.
Okay, you see the X on the left, the Y term on the right? Are they both on the same side? No. But can it be written in standard form? All right, so someone help me out. Raise your hand. Tell me how it can be written. Jenna?
4x minus 0 plus negative 2y.
So how do I change that from that first equation? Like, yeah, I get what you're saying, but how do I go from here? I'm going to subtract 2y from both sides. That cancels this out. And are these like terms? Nope. So I'm going to put 4x minus 2y equals 7. You guys see how I got that? So all I did was I subtracted 2y from both sides. Okay, that's nice. Is this in standard form? Okay, ready? I'm going to ask several questions of several individuals. Carson, according to this standard form, what is A? 4. Very nice. A is 4. You guys see that? It's the number or it's the coefficient of x. All right? Lucy, this is a trick question. There's only one right answer, and I hope you can get it. I really do. What's B? Very, very close. It's not just 2. It's negative 2. Now, why in the world is it negative 2, guys? Because I get what she meant, 2. Why is it negative 2? Okay, look at this right here. Ready? Look at this right now. I thought the standard form, I thought the standard form was AX plus BY equals C. And this says AX minus. Listen up if you're not getting it. Listen up. I'm going to read this in a different way, and if you're not looking up here, you won't get it. I'm going to read this in the form of in a standard form. Ready? 4x plus negative 2y. is equal to 7. Do you see it now? So B is going to be negative 2. Harrison, what's C? 7. That's the constant. That's the one that's by itself, doesn't change. By the way, do you know why we call them constants and variables? What's a variable? What does that imply? It can vary, or it can be anything. What does it mean by constant? Stays the same. Does 7 change? No. Can this change? Can that change? Yeah, it just depends. So that's why it's a variable, and that's why the others are constants in a sense. Okay. All right, ready? Another question for one of you. Brian, are A, B, and C integers?
Yes.
Yes. Lily M. Is A greater than or equal to 0?
Yes.
Yes. And the toughest question of them all. Emery, are A and B both not 0? You're looking everywhere but right here. Are A and B both not 0? Okay, so a little bit of it. Who knows for certain if A and B are both not 0? Jackson, what do you got? They are not both 0. In fact, neither of them are 0, so that fits. Standard form. This is standard form. Okay, ready? This is a question for all of you. You answer linear or not linear. So that's what you give me, linear or not linear. Is this linear or not linear?
Linear.
Okay, linear. Why is it linear, Jack? Because you said it very definitively. Because it equals a line, and this equation is written in standard form, so it has to be a line. Okay, good. Let's look at B.
Wait, so if you can change into something that's in standard form, it is linear?
If it can be changed, or if it can be written in standard form, it is a line. So it doesn't have to be written in standard form, but it can be written in standard form. That's the whole point. That's why I emphasize can be written. But this, can it be written in standard form? There's one little thing I'm looking at that's throwing me off. What's throwing you off right now? Exponent. Okay, in our standard form, did we have an exponent of 2 or 3 on either of the variables? No, because in fact, this is not going to be a line. It's going to be a parabola. Have you ever heard of parabola? So it's kind of like in this shape, like the parabola, or like this. Yeah, parabolas, frowny face. Yeah. Okay. Anyway, those are parabolas. That is not a line. And it is not in standard form. So here's another piece of info you need to get. If x or y, or both, have an exponent not 1, that is not 1. What's the exponent of y, by the way? 1. So if it's not 1, then this is no longer linear. So I would write not linear. Okay, so that's what you put for that one. Therefore, can you find A, B, and C? No, because it's not a standard form, so you can't find A, B, and C. Let's try this again. What happened here?
Somebody broke it.
Okay, let's see if it works. Please work. Okay, how about this? Go ahead and write down C, and then we'll look at it. I'll just calibrate and see if it works. I broke it somehow because it was working fine just not too long ago.
You say you try and break the Guinness Book of World Records for fastest time as you tomorrow.
Actually, I do try to beat my time, but I don't know about the Guinness. What do you think? Do you think I could do it?
Yeah.
Bummer. Okay.
Look it up.
Yeah, look it up. Oh, thank you. Okay, x equals 12. Is this in standard form, yes or no?
Yes.
Autumn? What? Hold on. Let me look at my notes real quick. It is. That's not cool. Okay, ready? It is. Thank you, Autumn. It is in standard form, but I don't see it. Okay, I'm going to look at 3 properties in the same problem. Please keep track of these because you're going to have to do this as well. What's the number in front of x? Okay, so doesn't it have an a because a is the number in front of x? So I can see it's 1x equals 12. Equals 12. Is it you? Okay, I can see that. But where's the y term? Where in the world did the y term? I mean, it's not there. It's not there. Wait. No, it's not there. Carson?
Plus 0, y.
Wait. Okay, you're saying 1x plus 0y equals 12. Okay, Carson, you're not allowed to do that, are you?
Yes, I am.
Oh, you are. Okay, ready? 3 properties here that are being used. All right, this first property, what's the property that says that 1 times a number is equal to that same number?
Identity property of multiplication.
Identity property of multiplication, that's the first one. All right, ready? Next one, what's the property that says that 0 times anything is equal to a big fat 0?
0. The 0 property of multiplication.
0 property of multiplication, second property. All right, here's the third property. Good idea. There you go. What's this property that any number plus 0 equals the same number? Any number plus 0 equals the same number.
The 0 of addition.
The identity property of addition, right? Adding 0 to any number keeps... All right, guys, I want you to confirm or disprove that this right here is equal to the original equation. Can anyone confirm it or disprove it? Because it's either one. I either made it up or it's correct. Thank you, Carson. Thank you, Autumn. This right here is in standard form. So, Harrison, what is A? What's A?
1.
1. What is B? Nate. B is 0. And what is C? Claire says 12. All right, who thinks they know standard form pretty well? You're getting it. Okay, Alex, I'm going to ask you several questions, okay? Okay, and you guys listen up because if she doesn't get it, I'm going to ask one of you. All right, are A, B, and C all integers? Yes. Is A greater than or equal to 0? Yes. Are A and B both not 0?
No.
Let me say that again. Are A and B both not 0? Okay, so you're saying it, but it's hard. Okay, when I say are A and B both not 0, the answer would be yes, because only one of them is 0, right? I know that's you're negating it by saying yes. Have you heard of double negatives, by the way? No. Okay, what double negative would make it a positive. So kind of like signs with multiplication, 2 negatives make a positive when multiplying.
No.
I will not.
So let me ask this question again. Rosalind, are A and B both not 0? Yes or no? Yes, they're both not 0. So is this in standard form? Okay, if this is in standard form, what kind of equation is that? Linear. It's got to be, oh, no, Mr. A. That is not a linear equation. Please work. Okay, good. Do you guys remember how this would be graphed if x equals a number? It's either got to be this kind of line or that kind of line. Do you guys remember? It's going to be the vertical. Do you remember that? X equals something where x equals 12 right here. It's going to be that vertical line. That's it. And isn't that saying that it's a line? So don't they confirm each other? And the answer is yes. In fact, if this B is 0, okay, if B is 0, it's going to be a vertical line. What do you think when A is 0?
It's not going to be a line.
Horizontal line. Very good. Using logic and my prompting of direction.
So that means in Spanish when you do no, no, yes.
Well, it depends how you say it. It really doesn't. And actually, something. I'm thinking of my son with language because he's picking up language from us. I say, Ezra, did you not, or what did I say? Did you not obey mommy? He says yes. So what is he saying? He did not obey mommy. He said, yes, I confirm that you're saying no, I did not obey mommy. What I normally say now as I grow up is when someone says, did you obey your administrator? Or sorry, did you disobey? Well, did you not obey your administrator? No. And what do I mean? I didn't obey him. But you see, technically the right answer is, yeah, I didn't obey. Right? Do you guys get how that language works? But we talk differently. He's understanding it from Mrs. A, who's very grammatically correct, and something that I'm learning. So if you say, did you not do that? Yes, I did not do that. Right? I'm confirming the not. But if I say no, I really mean I did do that, because two negatives make a positive. So that's language, and that's proper. And when you're writing it down, especially, you want to communicate the right thing. One of these days. Okay. How about this? Go to page 283, and we're going to start working some together here to make sure you guys get this. Remember that world record? Yeah, I lost. Okay. Oh, actually, you know what? I'm sorry. We're not going to do those problems right away. Let's do up above number 6. Number 6. Yeah, these are good ones. So just right above the homework area. 3x minus 5y equals 0. Okay. Jack says linear. Give me all the reasons why. Can you do it? Can you give me every single reason why? There are many. Okay, Jack, go ahead.
Well, number 1, A and B are not equal to 0.
Close. A and B are both not 0, right?
Yeah.
Okay, good. I'll take that. 1.
A is greater than or equal to 0.
Good. A is greater than or equal to 0.
And
What about all 3? A, B, and C? They're all integers. Are the variables on one side?
no, yeah.
Yep. Is the constant on the other? You're like, 0? Can that be a constant? Yeah, 0 equals 0. That's a constant. Okay, let's see here. Nate, what's A?
3.
Lucy, what's B?
-5.
Very nice. And what is C, Claire? 0. Okay. Yeah, it's a 0. Is this linear or not linear? Carson? Linear or not linear?
Linear.
So you would put linear. Okay, it is linear, despite what my pen says. All right. That was too easy, I hope. Let's look at number 7, and I want you to do this one on your own. I can't wait till I get my new screen after Christmas break. It'll be my Christmas present. In fact, my class will be facing now that way, which is awesome. Yes. Sorry? Let me write this down and I'll bring that up. 2x equals 6 minus y. Is that in standard form? No. Can it be written in standard form? Then do it. Go ahead and do it. And then I'll ask somebody what they got. Sorry? Yeah, and this is the first part of the lesson. And let me give you why I like this part. Standard form is going to help you on this. Slope-intercept, point-slope forms. And there are other ones, but those are the two main ones. And then you can look at an equation, and you'll be automatically saying, yes, that's a line. Or no, that is not a line, just by looking at it. Okay, Lily G. What is the standard form of this? And then I'm going to ask somebody else how she got that. So go ahead.
Is it 2x plus y equals 6?
2x plus y equals 6. Okay, that looks like standard form, but Jenna, how in the world did she get that?
She has
She added y to both sides and then rewrote it 2x plus y equals 6. All right, good. You can say 1y, but you don't have to. We understand it's 1y. Right? How many of you got that? Either that or without the 1. Good? All right. Next one. Ooh, number 8. X squared plus 3y equals 4. Okay. Harrison, is this in standard form?
No. Yeah.
What? Yep. Wait. Final answer. Yes or no?
Yes.
No.
You should have stuck to your guns. All right. There. It looks super standard. There's just one big problem. Is that what it was?
What?
This exponent.
What
Hmm?
was the word called? You know? It was like
Standard? Parabola? Oh.
Yes, that.
Yeah, this would be a parabola. It is not a line. By the way, guys, I hope you understand. Jenna, Jenna, it wasn't that shocking, okay? That's a parabola.
Harrison, what did you do? Harrison will be.
I'm not sure why it's doing that.
Maybe you ran out of space.
I don't know. Okay, Jenna, you mind? Sorry. There you go. Yes, ma'am.
In order for it to be linear, do the variables have to be x and y?
No. So here's a good question, and this ties back to last couple lessons. All right, ready? The question was, if it's linear, do the variables have to be x and y? And the answer is no. Remember yesterday, some of your variables were a and b, right? So it could also still be linear if you can write in standard form, or g and h, or whatever variables you have. So yes, it doesn't have to be in x and y terms. All right, let's look at number 9 down there. No, you look at number 9. Go ahead and do number 9. And see if you can write that in standard form. And I'm going to go over, in this problem, over something that's very important in algebra that helps me with equations and inequalities. But in equations, number 9 is 3x plus 2y equals, oops, that's not the original. 3x equals 7 minus 2y. Okay, what would you have to do to get that y over to the left side? What would you have to do, Emery?
Add 2y.
Okay, here's a principle in algebra that I'm going to allow you to use now. Okay, yes, you would add 2y to both sides. Basically, am I not taking this term right here and moving it over to the other side by changing the sign? So don't I get, instead of negative 2y on the right, what do I get on the left? Positive 2y, right? Right? So we talked about this last year a little bit, but I want to remind you, and this is an important concept, I hope I can write it down. Whenever you change sides of a term, whenever you change the sides, so you see here is on the right, now it's on the left, you can change the sign. Change sides, change signs. And this is really important because it helps simplify your work. And some of you are like, I'm not even looking, I don't need to know that. I'm trying to help you out. Especially on this lesson, it'll help. So let me show you this problem real quick. Okay. Okay. Let's go with negative 2y equals 6 plus, or let's go minus 2x. All right. Okay. You want to get that x over, don't you? aren't you going to change the side? So what are you going to do with the sign? So I can rewrite this automatically like this. 2x, which is now positive, minus 2y equals 6, right? It's automatic. So we'll finish this up after. All right. Have a good day, guys. So we got Ezra. We saw it's this Thomas the Train Superstation. It's this giant superstation. Wow. It's a big monster, big thing. That's it.